Hello and welcome back. This is lesson 6 for Science 10 Chemistry at Center High. Today we're going to be talking about atomic number and atomic mass and using the periodic table to do some calculations to figure out the number of subatomic particles for different atoms on the periodic table. Recall that the atomic number of an element is always equal to the number of protons and electrons. I'm just going to change my pen. And electrons in an atom. I want you to highlight or underline the word atom there, because you're going to see that this is different than an ion, which we brought up before, but that will come back later. For example, what is the atomic number of calcium? To answer this question, we're going to go to our periodic table. And you can see calcium, if you're following my little cursor here, calcium is number 20. The atomic number is the number in the top left-hand corner. This periodic table looks a little bit different than the Science 10 version, but it is the exact same. So if we look here, this is our atomic number. That's number 20. This means that the calcium atom has 20 protons and 20 electrons. The atomic mass is always equal to the average number of neutrons plus the number of protons. In the atoms of a naturally occurring sample of the element. Something I want to focus on here briefly is that this average number only applies to the neutrons. There is no such thing as an average number of protons because calcium is defined as having exactly 20 protons. So if you were to change this number, it's no longer calcium. However, the number of neutrons could change for calcium between 20 and 21. And how do we get to that number? Let me show you here. First of all, we look at the atomic mass, which on your periodic table is right here. On the one that I'm using, it's on the bottom here. This is the atomic mass. It's going to be the decimal number because it has that average number of neutrons. The atomic mass of calcium is 40.08. To calculate the number of neutrons, because atomic mass is neutrons plus protons, we can rearrange that with a little bit of algebra. So I'm just going to write that here. So to show that, atomic mass equals the number of neutrons plus the number of protons. If we wanted to rearrange this to solve for the number of neutrons, we could subtract the number of protons from both sides, and we would get this equation here. Atomic mass minus atomic number, which is our number of protons. Let me be color consistent here. Atomic mass minus the number of protons will give us neutrons. That's this equation here. Atomic mass minus atomic number. Remember that atomic number is the same as the number of protons, and because neutrons and protons carry most of the mass, we can combine those two numbers to find their atomic mass. One thing that I need to lay out here. You can't have partial neutrons. Note that the atomic mass number is a decimal. If I was going to take this number, 40.08, and subtract my atomic number for calcium, which is 20, I will get a number of neutrons as 20.08, but I can't have partial neutrons. let me just write that out here. 40.08 minus the 20 protons that I have would tell me that calcium is going to have 20.08 neutrons. But you can't have partial neutrons, so we will round this to 20 neutrons. You can do the rounding in either step. I prefer to round at the atomic mass before I do the subtraction. So you have to round to the nearest whole number. Because you cannot have partial neutrons. So let's take a look at the following here. When you're looking at the periodic table, we are ignoring this bottom piece right now. This refers to the ion. This refers to the ion. This refers to the ion. And we don't care about the ion right now. What we care about is this information, which is the atom. So if you're just looking here, the number of electrons is going to be the atomic number because this is an atom. So we're going to have 11 electrons. And the number of protons is also the atomic number. It's always the atomic number. We have 11 protons. To find the number of neutrons, we're going to take the atomic mass, which is 22.99. I'm going to round it to 23 because I can't have partial neutrons. And then I will subtract my atomic number, which is 11. That will get me 12 neutrons. Over here, if we look at an atom of selenium, the number of electrons is going to be our atomic number, that's 34. The number of protons, also our atomic number, 34. The number of neutrons, we will take our atomic mass, 78.96. I'm going to round it to 79, and then I will subtract my atomic number, 34, which will get me 45 neutrons. For the smaller atoms on the periodic table, you're often going to find that the number of neutrons is pretty close to the number of protons. If you look at calcium, for example, we just did the calculation. It's got 20 neutrons. It also had 20 protons. But as you get larger on the periodic table, you will note that the atoms start to have larger and larger numbers of neutrons. This is some practice. I would encourage you to try this practice out on the next page. Just find what's your atomic number from the table, what's the atomic mass, number of protons, number of electrons, and then do your calculation of atomic mass minus atomic number. To get your number of neutrons. Make sure that you round. Make sure that you round to the nearest whole number. Go ahead and give that a try. So pause the video now, and then I will run us through platinum just as an example, just for one more time. So go ahead and pause the video, and then I'll go through how to do it for platinum. So hopefully you've had a chance to try the table now. I'm just going to do platinum as an example. So we're going to go to our periodic table. I know my periodic table looks slightly different. Platinum's number 78 right here. So platinum 78 is the atomic number. That will tell us our number of protons and electrons. And our atomic mass is down here, 195.08. So if I'm filling this out, my atomic number for platinum, 78. Its atomic mass, 195.08. The number of protons is the same as the atomic number. Because we're talking about atoms here, then our number of electrons is also the same as our atomic number. In order to figure out our number of neutrons, we will round our atomic mass to 195. We will subtract our atomic number, and we will get that platinum atoms have 117 neutrons in their nucleus. There's some more good practice questions down on this page. I would encourage you to try it out, just looking for more calculations for the number of neutrons, and just practice using that periodic table. That's all for today. The next lesson we will talk about ions and Bohr energy level diagrams for atoms. Actually, we won't talk about ions, we're just going to talk about Bohr energy level diagrams, and then we'll get into ions in the lesson after that.